Yeah, many 4 students have not replied. Okay, Pam, Ravinder Kumar Thakur. Okay, so we would like to proceed further. I'm going to share screen with you guys. So let's have a look at what we are trying to do today. We have studied this FTIR spectra. How does it work? And after that, we would like to start with the new topic, which is SIMS measurements. Okay. So what we have done till now, that in case of the FTIR spectroscopy, we have very straightforward things that we are trying to excite the rotational and the vibrational states of the molecules. So most of the materials, they have the fingerprints in that region. Okay. So what we have seen, that if you plot the transmission as a function of the wave number, in that case you would have the spectra, which is known as the FTIR spectra. And what are the different type of the elements which are required? Like if you need to have different type of the sources and different type of the detector which are required in the case of the FTIR spectra that we have discussed in detail. Overall aim is that we have tried to address that how does an FTIR spectrometer works, what are the uses of the FTIR spectrometer, and how to change your FTIR spectrometer corresponding to the wavelengths, because it's not like that you are working on a single wavelength. Maybe the variety of the people, for example, chemistry people will be more working like the molecular level or the organic molecules level. Physics people, they are working like in the materials which are the solid state materials, the material science. In that case, in all of the cases, we have to see that which kind of the beam splitters and which kind of the detectors and sources have to be used. Overall aim of this FTIR spectroscopy was very clear, which we have discussed. Now let's come to the secondary ion mass spectrometry. And in short, we will say that this is the SIMS measurements. And in this case, okay, we have also tried to address this issue with the help of dissertation student Pavanjot, but to some extent he was not. I mean that he tried his best, but he was not prepared for this. No, and the basic principle remains simple. It won't be any problem for us to understand that how does this spectrometer works. And later on, what we can do that if we are going into the details of this secondary ion mass spectrometry, and how this setup can be used to get real-time information about the sample. So what type of the elemental composition is there. So with the help of this SIMS measurements, we can go for the elemental composition, we can know that what type of the elements are present in the system, and it has several advantages because this setup can give us much more accurate and precise information about the layer structures. So let's see that, okay, how does this secondary ion mass spectrometry works. And initially, so what we can do with the help of this the secondary electron mass spectrometry, that we have to see. So, so if you would like to have if you want to know about the elements, okay, element, elements, and elemental composition, elemental composition, elemental composition. So in that case, what you can do that you can just look for this SIMS measurements, how this SIMS measurements will be helpful for us. No? So if you recall that what are the different type of the instruments which are involved in this case, that we have to see one by one. So first of all, let's have a quick look at the experimental setup which is there. So if you would like to have an information about the source which is used in this case, let's have, okay, you have a source, and okay, so from the source you would have the sample like this, and here you would have like uh, let's say like this. And after this, if you look into the details, then we would have this the detector. Okay, the detector will be somewhere. Okay, let's see it. It would be here. Okay, so with the help of this these things which are there, we have to see that how this setup works, no? With the help of the information which we have. If you look into the information which we have, is that in this case, if you want to have a look at it, in that case you would have let me pull out this information for you. So you would have the electrons, the ions which are incident on the surface of the sample. That is the first thing which we need to have. What we have, this is the ion source. This is called the primary ion source. Primary ion source. Ion source. And after this, we would have the sample. Okay? And the sample, after the sample, what will happen that these ions will be directed towards the mass analyzer. But you would have this portion which is there, it would be the mass analyzer. And after that, what will happen that you would have let's say if you are here, something like this. So you would have, let me find it out for you. Here you would have the detector, which will detect. It can be like an electron multiplier, okay, or any other detector, okay, electron multiplier, like you find in case of the multiply tubes. So what we would have in this case that you would have two types of the ions. So here you have this is the primary ion source from where you would have the ions which are incident onto the surface of the sample. So basically the beam of the ions which will be the incident onto the surface of the sample. Okay, so that will be directed in this case. And after that, what will happen? These ions which are there, so they will produce the secondary ions in this case. What they will do that they will give you the secondary ions in this case. Secondary ions. And with the help of this mass analyzer, what you can do that you can separate the ions on the basis of the mass to charge ratio, okay, which is mass to charge ratio. So what will happen that in this process you would have the detection, okay. First of all, the what is we have not given the detail in this case that how does it work, but only idea is that we are giving a pretty a rough idea that how and what are the components of this secondary ion mass spectrometry. So if you have this information with you, then we have just a minute. Okay, so let's have a quick look what we are trying to do in this case. So the primary ion source will give us the ions in this case, and these ions they will be incident onto the surface of the sample. These ions can be like your depending on the requirement. That for example, if you have the cesium ions, let's have a look at it. You can have cesium ions, you can have O2 ions, okay, or any heavy ions which can sputter the material from the sample surface. Sorry. So what we are trying to say in this case, that you have the heavy ions which are directed onto the surface of the sample. So from here, what will happen, that there is a possibility of ejection of the secondary ions. So what will happen in that case, that you have this sample, and sample will give you the secondary ions. And why it will give you the secondary ions? There will be many processes which are going on there. Like there is a process known as sputtering. So there is also called sputtering. What is the meaning of sputtering? That this is the process of uh, um, when you bombard a sample with the heavy ion. In that case, what will happen, that you have some of the material will be removed in this case from the sample, and that can be in the form of the secondary ions. Okay. So the process of removing the material from the surface of the films, okay, then it is going in the different direction, that is known as sputtering. Okay. Sputtering means just um, when you the example is that if you have mud wall, if you have mud, you put you throw a stone into the mud. In that case, what will happen? It will give you, what will happen? There will be some mud particles which will be scattered in all the directions. Okay, same is the process in the case of this the sputtering. So what will happen, that the material, actually that material that comes from, okay, yeah. So that material which is coming from the surface, okay, that will be the sputtered material in this case. You have both the possibilities of sputtering. You would have possibility of the secondary ions which are emitted during this. Once the secondary ions are these are produced in this process, in that case, what you would have the separation in the mass analyzer. So you know that what would be the effect on the ion. For example, if you have any type of the ion, if you apply the magnetic field across the ion moment, in that case, you can separate them in the space. So this is simple. Like what you do, that if you are, okay, if you are applying any magnetic field or electric field also, so what you would have, that in that case, the incident electrons which are coming, let's say that if you have a bunch of the electrons or the ions, okay, so the ions which are coming here, let's say if these are positive charge ions, in that case, what will happen? They will get the force, which is F is equal to what you know, that okay, Q V cross P, P cross P, P cross P. Mhm. Their trajectories will be changed according to the Lorentz law, and they will be deflected as per the V cross P. Okay, V is the velocity of the ion which is incident, and B is the applied magnetic field. Q is the charge on the ion which is incident onto the surface of the material. What will happen, that this mass analyzer that will separate it. Okay, so and it will not direct all of the ions to the detector. What will happen, that the this the detector now it has a window which is opening there. Okay, let's say that if you have this much window of the detector which you have opened, in that case, what will happen that the ions which are incident in this case, the ions which are coming from here to here, they will be only in one energy range. Okay, so what will happen that you would have if these are heavy ones, then in that case it will be separate. These will be separated on the basis of the mass by charge ratio. If you have a heavy ion, in that case it will be affected differently. If you have a light ion, then it will be affected differently. When they go to the detector, in that case, if you have a multiplier, then what will happen? You would have many possibilities. Okay. So what you are trying to do, in case of the electron multiplier detectors, what happens that you have diodes. Okay. So you would have diodes which are at a variable potential in case of the detector. No? So what happens normally that when these are the diodes, okay? Diodes. So what is their function? That, for example, if you have incident particle or the ion which is hitting these diodes, in case what will happen, these diodes, they will give us the required electrons. Okay? For example, if you have one ion, that this dynode is from the dynodes. What is the uniqueness of the dynodes? That it can easily eject the electrons. What will happen then? In that case, you would have one ion, and corresponding to one ion, you would have the liberation of the, let's say that electrons. For example, if you have this electron from here, okay, so this is the electron, and this will be directed from here. You would have the two electrons which are liberated. In that case, what will happen that you would have this process will be multiplied in this case. No? This process will be multiplied in this case into the thousands and thousands of electrons, or which will be going to the detector in this case. Okay, so you would have roughly one ion. Can you assume that many electrons can be produced corresponding to one ion? Okay, so you can have this the knowledge of this ion which is coming over there. So corresponding to one ion or one electron, okay, there will be about 10 raised 1 10 raised power 6 electrons which are generated finally. Okay, these are 10 raised power 6 electrons which are generated finally. So what will happen that this process is known as electron multiplication. So what you would have ultimately some of the information which is uh, so you would have a greater signal when it goes to the final dynode in this case. That is the basic principle of the this electron multiplier. That how does it work? No? So I hope that the things are a bit clear in this case about the elemental composition, how to do it exactly. That we have to see in our next lecture. So can I have one? Okay, I have one question. The small questions. Okay. I'm just writing two options for you. Can you answer the query? Thirteen students have not replied. Please reply. Yes, please reply. 8 students have not replied. Basically, the question is related to this part where we are trying to separate the ions on the basis of this mass to charge ratio. Basically, what will happen that you would have the Lorentz force which will be acting in this case, and this Lorentz force that will depend on something. So if you look into the details, then you can answer this query which is given in the question. Because secondary, how you will collect the secondary ions, that will be an issue in the case of the this SIMS measurements. Let us see that how many 3 students have not replied. Okay, okay, so we have okay, most of the students have both 1 and 2. So I think all of you are most of you are wrong. It's magnetic field. Okay, magnetic field. So if you look into the magnetic field, so what will happen that it is like your the electric field that accelerates the charged particle, and the magnetic field that changes its trajectory. So if it gives you curvature when it is in the magnetic field. that we have to take into account in this case. But both, the role of both are there, okay, electric field as well as magnetic field, but the trajectory, curvature of the path of the electrons, that will be based on magnetic field, okay, how much magnetic field you are applying. So let's have another query. The work function of the dynode material should be low, high, no effect. Okay, so can you answer this query? The work function of dynode material should be low, high, no effect. Please answer this query. Reply, please, hurry up. Reply. Okay, and leave the session. I think most of the students they left.